So let's do a few of these together. So remember, if two things multiply, that, like here, they multiply, that one of them or both of them equals 0. So we're just going to be able, whenever it's equal to 0, we can know this for sure. This doesn't work for any other number. This is equal to 1 or 5. It's not true, because when you multiply any number by 5, it really could be any answer. But when you multiply anything by 0, its answer is always 0. So 0 is important to have on the right-hand side. Okay. And then we can solve each one individually, add 2 to both sides, x equals 2. Add 4 to both sides, x equals 4. Right. But more importantly, what does this mean on the graph? Okay. So if we were to draw an axis, sketch it, of course, nothing super accurate, we want to understand that these two numbers, first of all, the reason it's x is because it's the x-axis. So x equals 2 and x equals 4. Those are the launching and landing points for this parabola. It's where it crosses the ground. Think of the x-axis as the ground. However, since these are all positive, there's no negative GCF, it's all facing up. It's going to look like this. So go ahead and draw your best parabola that goes through, hopefully, not like mine, I missed a little bit, but goes through both of those points. Just to show that you understand that this is the answer doesn't mean, oh, it's just the answer, but it physically has a location on the graph. Anything else? I think that's it. By the way, we don't know other pieces of information. Later on, I just assume this, I just sketched this, but it could look like this. Right? I don't know exactly where this vertex is. I'm just guessing at this point. It could go way down here. So your graph or your sketch will be different from one another. The only thing that's the same is that it goes through 2 and 4. But the rest of this week will be devoted to, well, yeah, how do we know exactly where this vertex is? You know, not kind of estimating like we are today, but exactly. So just know that's coming down the way. And what if it doesn't have, you know, it's not a plus or a minus like here. This just had a GCF of x. So if we had like x squared minus 6x equals 0, they factored out an x. They did the first step, find the GCF. They took out the x, then they got this. And whenever you have a GCF, it operates the exact same way. It's still a factor. So you just say, well, that left-hand side equals 0, and then you're done. There's nothing to add, subtract, or divide. So that's what's different when you have a GCF as a factor. Okay, so we'll get 0 and 6. So where is x equals 0? What's another name for that? X equals 0? Yeah, it's the origin. It's right here. That's where x equals 0 and x equals 6. 1, 2, 3, 4, 5, 6. So I know my parabola goes through here. Try to make it as symmetrical as possible. Well, since 0 and 6, what's the middle of 0 and 6? 3. So if you go 1, 2, 3, I know my vertex is somewhere on 3. It's in the exact middle always. That's what the definition of the vertex is. It's in the middle. So I can draw a third point, and that'll help me sketch it. That's why it's a nice, valuable point to have. It's not even going to tell us how high or how low the parabola goes, but it's a nice middle point when you're graphing. Okay. I don't know how low, I just know it's in the middle of 0 and 6. Okay. Let's see. Anything else here? Okay.
On number
let's go over to here, number 3, real fast. They're not always going to be these nice numbers. So once you start seeing like coefficients of the x, and you start solving these, you'll notice you start getting decimals, which are okay. It's like when you go to buy things, not like everything costs exactly $2 or exactly $5. There's going to be change. So if you get decimals, don't say, well, something's wrong. I must have messed up. It's fine. So we have 2x equal to 5. So x is 5 over 2. And a fraction, a reduced fraction, is just fine. That's acceptable. However, when you're sketching or graphing, you need to know where that is on the number line. Most of you would probably do this by change it to a decimal. Okay. So what is 5 over 2 as a decimal? 2.5. Yeah. And then same thing over here. If you subtract 4 on both sides, 3x equals -4. So divide by 3, and x equals -4/3, and that as a decimal is yeah, 1.3 repeating, which will round to -1.3 approximately, because I rounded. Okay, so here you could say, okay, here's 0, -1, -2, +1, +2, +3. So we'll have 2.5, 2.5, which is right here in the middle, and -1.3. So here's -1, -1.3, right about here. And then you can go ahead and sketch using that. So it's just a parabola, looks something like that. We could calculate exactly where the vertex is. We could find out exactly the middle of 2.5 and -3.1. The middle, or the midpoint, is the same as the average. So if you add those two and divide it by 2, you would get your middle point. But we'll worry about that again later. Question? If it doesn't equal 0, you have to get it equal to 0. Because we can't use the 0 property. We can't say this, one or the other equals 0, unless it's equal to 0. Okay. So yeah, if it's not equal to 0, like some of them are, like 9, well, we know, well, -8 plus what is 0? Yeah, you just add 8 to both sides, and now it equals 0. So you can continue on. So the last, oops, sorry, way wrong. Yeah, -6x plus 8 okay. So then you can go through. Oh yeah, the last, when you're factoring, the first step was always look for a GCF, look for a GCF, look for a GCF. Well, now that you're solving, your first step is actually going to be get it equal to 0. Then look for a GCF, then decide if it's a difference of squares, or do you need to use the x, and all those other steps. So always get it equal to 0 before anything else. If possible, keep this positive. Because you might have a choice, like on this one, I could have subtracted x squared to both sides and added 6x. It'd be equal to 0, 0 on the left. But then you just have an extra step of having a negative GCF, so you have to do one more step. So if you keep the x squared positive, it'll keep the workload down. You won't have that extra step added in. Okay. All right. Look in the back. Anything here? The rest is all good review for factoring. There could be prime, there could be GCFs, there could be difference of squares. They're all mixed together like those first 2 homeworks last week. Okay. So if you get stuck on them, just think of it that this is a homework problem from before. Follow the same steps you did before. Don't have to think of a new way. The only thing that's new today is right here, set an equal to 0, and that those answers actually have a location. on the graph. Okay? Okay. So the last thing is number 6. You look at this, and there are 3 factors. So we just got saying the factors turn into roots, which turn into a physical location of where this thing is leaving the ground and hitting the ground, going up and coming back down. So what does it mean if you have 3 of them? How can this go up in the ground, hit the ground, but hit it 3 times? The answer to that is it can't, because it's not a parabola. A parabola has a highest exponent of 2, x squared. That's the highest it goes. If we multiply this whole thing together, it's going to go up to x cubed. It's going to be the 3rd power. Now, you'd still do the exact same steps. We're still multiplying 3 things, and it's equaling 0. That means 1 or all or 2 of them equals 0. So we'd still say, well, x equals 0, x minus 3 equals 0, 2x plus 3 equals 0, and you'd get your 3 answers. Okay? But how to graph that? Okay, the graph is going to be in Algebra 2. So we're going to focus only up to the 2nd power. And then when you get to Algebra 2, the nice thing is you can see it's the exact same steps as you do for 2 factors. They're just, 3 of them, and you get the same thing. And this is still where the graph crosses 3. It just crosses 3 times. So let me show you what that looks like, just to get a sneak preview. Oops. So if I take this and graph my 3 factors, there's x, which is just a straight line. But when I start combining it with other things, like x minus 3, now it's a parabola because it goes up to x squared. But when I add in another factor, every factor is another root. If I put in plus 3, now it looks like that. Right? And it's equal to 0, so you can see it crosses 3 points. So that's Algebra 2. You don't have to worry about graphing these, so for that problem, you don't have to do a graph. But just know everything you're learning now, Algebra 2 just takes it up to, well, what if it was to the 3rd power, 4th power, 5th power? How many answers? How many roots are there then? And you just kind of do the same thing that you've learned already in Algebra 1 and extrapolate it for higher degrees. Okay. So that's something in the future. After you take geometry, you go to Algebra 2 and come back and learn this. Okay. All right, so that should be good. Remember, get it equal to 0 first. Always look for a GCF. Then do the proper factoring, and then you can do a sketch. There will be prime, so you have to think about that also. Okay. All right. So we got plenty of time. We got, what, half hour? 25 minutes? Yep, lots of time here. So make it worthwhile.